Hi everyone, it's Coral here. Thanks so much for coming to our webinar. We really appreciate your being here. So today's topic is a comparison between OGC Sensor Observation Service SOS and OGC SensorThings API. It's going to be presented by Steve Liang, who's a professor at the University of Calgary and is the author and editor of the SensorThings standard. So he has a very deep knowledge of the field, and I hope that this topic will prove really useful for you. Before we get started, just a couple of housekeeping items. If you go to the edge of your screen, you'll see that there's a Q&A and a chat button. So please feel free to ask us questions. Just click on Q&A and a panel will pop up, and just type them in and we'll get to them at the end. And if you want to raise any concerns, go ahead and click on the chat button and let us know what's going on, and we'll get back to you. So without further ado, I will pass you over to Steve, and at the end of the webinar, I will put up the link at which we're going to be posting the slides and the recording of the webinar.
Okay, hello everyone. Welcome to our webinar, and then good morning, good afternoon, and good evening. And we do have registration from everywhere around the world. It's quite exciting. And so today we're going to talk about the difference between the OGC SOS, Sensor Observation Service, and SensorThings API. So before we do that, a slide about me, but most of you might know me already. I'm a professor, and as well as the founder and CEO of SensorUp. I've been involved in OGC sensor web enablement for more than 10 years, a long time. Some people said they didn't believe that, but yeah, I was involved at the very beginning. So one slide about SensorUp. We consider ourselves as a leader in sensor web and IoT platforms. We're leading several international IoT standard development efforts. OGC IoT. We're a proud member of Eclipse Open Source Foundation and OGC. And some news from us, I think it might interest a lot of you, is Whiskers. And we recently submitted a proposal to the Eclipse Foundation for SensorThings API. And so it has the proposal is online right now. It's a Eclipse open source project proposal for SensorThings API. And the Whisker project has two components. The first one is a JavaScript client library for SensorThings. So it will have a JavaScript library, and in the future we will have more for this. For example, like a leaflet plugin is on the roadmap, or a charting library based on the core JavaScript library. So please stay tuned. And the second part is a lightweight SensorThings server for IoT gateways, for example, like a Raspberry Pi, so that you can connect your sensors to a Pi, and the Pi become a SensorThings server. This is what on our plan. And the first release is scheduled in 2016 Q2, so this year, the second quarter or the third quarter. So please stay tuned, and maybe you can consider to contribute and join our open source community and effort. Okay. Okay, so let's dive into today's topic. So the difference between the SOS and the SensorThings. So background. So the background about SOS. So SOS, the first version is a result of OWS3, OGC Web Service Testbed 3, back in 2005. So after the testbed, and we worked together and to created the first standard of the suite of sensor web standards. And then on your right-hand side, actually, on the slide, you can see that that's the actually one of the very first integrated suite client developed by me. Actually, I was involved in this. So that client was a virtual globe client. It's able to connect to SOS, SPS, catalog, and then WMS, WCS. Okay, so that's the story, so 2005. And then SOS 2.0 was approved in 2012. So that's the background of SOS. And SOS basically is a web service standard from OGC, allow you to retrieve observations as well as the relevant metadata of the observation, including the procedure or sensors and feature of interest, and so on and so forth. So background about SensorThings API. So OGC conducted several IoT workshops back in 2011 and 12 and identified the needs for a new SWE standard for IoT. As a result, the standard working group SWE for IoT was established in October 2012. And then in September 2013, and we had this meeting in Frascati, and then we decide, what is SWE for IoT? Nobody knows what that means, right? Except you are very familiar with the OGC standard. As a result, we changed the SWE for IoT into SensorThings, and thanks to Denise, her proposal, so SensorThings API. And SensorThings API was finally approved in February 2016. So it's the official OGC standard. So here's the thing. Both standards offer a web interfaces and encodings allow you to exchange observations. So a lot of people ask the question, what's the difference between them? Why do we need two? And hopefully today we can give you some idea. What are the differences between the two, and some comparison. Okay, so first of all, my group implemented multiple SWE services all the way back to 2005. Actually, back in 2003, I implemented a sensor collection service at the time. It's before SOS. And so we have experiences in SOS 1.0, SOS 2.0, and actually implement couple of them. And we had the Whirlwind-based SWE client, so virtual globe-based client. We had the Ajax-based SWE client, and we have a people viewer for SensorUp browser, and so on and so forth. And during the process, we learned a lot from the pros and cons about SWE standards. And we published more than 20 peer-reviewed papers and to share our experiences and the algorithm, how to make it faster and more efficient. And when we designed the SensorThings API, we tried to apply the lessons and the papers we wrote and then to the development of SensorThings API. So what are we comparing today? So these are the things we are going to compare. The first one is interoperability. So because we have two standards here, so can these two standards interoperate with each other? And I think there's a lot of people in this question. The second one is the features. So feature-wise, what are differences between the two? And the third one is the developer experience. And a lot of people, they think, oh, the SWE standard is quite complicated and it's not very developer friendly. And as a result, actually adoption is not very, very good actually. It's good, but not as, when we talk about 50 billion devices connected around the world, and then definitely we need to provide a better developer experience. And efficiency. Sensor data, fit the big data criteria, right? Like volume, velocity, and variety. So is it efficient enough so that the standard can accommodate so many sensors? And scalability. Similarly, we need to the standard need to be scalable, so that we can accommodate many sensors and even much more data collected by the sensors. And finally, security. And IoT security is a very hot topic. So what do we mean by security? Okay, so interoperability. So I'm very happy to share with you at the data exchange level, SensorThings and SWE, SOS are interoperable. Why? Because both are based on OEM. So that's a great thing about have a conceptual model. And if we start from this conceptual model, and they are supposed to work with each other. And actually, last week I was in Internet Architecture Board meeting, a workshop about semantic interoperability for IoT. And then while a lot of people are still debating, okay, what does it mean by conceptual model? What does it mean by information model? And OGC is really leading the way. We based on conceptual model, and we have logical model and physical model, right? The different encodings, and they are supposed to work with each other very, very nicely. And our experiment shows that it works very, very nicely at the data exchange level, and at service interface level. So from SensorThings to API to SOS, yes, you can directly have one-to-one mapping from SensorThings to SOS, but not vice versa, not the other way around. So SOS to SensorThings No, you cannot do that. And next slide will show more details. So SensorThings to SOS, and you can build a SOS with SensorThings API directly. So that means you don't even need to touch the database. It directly uses the API and then do a conversion of the encoding. And you are good to go. So that means function-wise, you can find one-to-one mapping from SensorThings to SOS. And I'll give you an example, like SOS version 2.0, example 9 from the spec. So get observation for certain observed property. And you can have a direct translation into SensorThings API query, so which is observed property ID. So this is a RESTful way. So for this observed property, what are the data streams? And I can expand the observations of that data stream so that observations of those data streams will be returned back from that request. For that request. So that's function-wise, these two queries are very, it's one-to-one mapping. And for SensorThings, after you get the JSON back, you convert to XML according to the SOS schema. Voila, and it's a SOS response. And of course, you need to write a controller to handle how you parse the request. But that's just a separate module. But function-wise, it's there. However, SOS to SensorThings, not really. And I'll give you an example. So for example, a use case is find all observations whose feature of interest description contain Arctic. So let's say I want to have all the observations that observing some features, and the feature has a description about Arctic. So in SensorThings API, again, it's one line. So you start from the features of interest, a collection, and then you filter to find the Arctic, so substring of Arctic, and in the description attribute, and then you expand observations. And you can get all those observations that are monitoring the Arctic feature of interest. And however, SOS doesn't provide this function. And there are many different examples that the SensorThings API provides some function and query, but SOS just cannot implement them. And actually, the reason is SensorThings API is based on OData URL query and the URL resource path, and it's like a SQL for the web. So it provides a lot of flexible way, allow you to get the data you want. It's very powerful and very flexible. And so the good thing is, combine ONM with this very flexible query language and the very powerful URL resource path, and you get something very flexible and powerful here. So in a way, SensorThings API provide a lot of analytics function. Allow you just using one line of use your address bar, and you can perform the query. So it's very nice. Okay, so features comparison. So actually, this is I copied from the Wikipedia page for the SensorThings API. I wrote this on Wikipedia, so you can go check it out, and you can contribute here. And then, so here's the list of features of the differences between SensorThings API and SOS. So if you look at it, the encoding, they are different, JSON and XML. So that's a difference. At least for now, nothing stopped SOS to have a JSON encoding, and nothing will stop SensorThings API to have XML encoding. It's just encoding. And architecture style is quite different. SensorThings is REST, resource-oriented, and SOS is service-oriented. So if you need to add more function into SOS, and you need to add one more function, so one more service interface. For example, people are talking about to have a get availability request, a new interface for SOS, right? And so more function to add more a service interface there. So binding REST for SensorThings API, and SOS is SOAP. And the function-wise, so SensorThings API is very easy for sensors or developers to insert new sensors or new observations. It's very easy, and I'll show you some code later. And by using HTTP create, HTTP post. Post. And then for SOS, basically you need to use a SOS specific interfaces like register sensor and insert observations. So the good thing and bad things is, for the good thing about SensorThings API is if you know you're familiar with the REST web services, and then if you look at the data model, okay, you know how to create insert the new readings into the SensorThings API. No more, you don't need to read the spec basically because it's follow the REST a pattern, right? And for SOS, you do need to read the API and you look at, okay, what are the parameters and so on and so forth. Okay. The next one, deleting existing sensors. So sometimes you need to delete sensors because they are offline and you don't need them anymore. So for SensorThings API, it's HTTP delete. It's very, very easy. Just a header with a resource path, you're done. And for SOS, it has a specific function called delete sensor. Okay, for next one, pagination. SensorThings provide pagination, so allow you to retrieve a subset of a entity. Okay, so like I only need the top 5 results, for example. And in this case, for example, SensorThings provide top, skip, and next link for pagination. And pagination is very, very important for scalability reason or efficiency reason because you don't need to transmit all the data you need at once, right? You can do it separately. However, SOS currently in the spec, it doesn't support pagination. And next one, publication subscription. So publish and subscribe, and then so pops up SensorThings are using MQTT, and then we have an MQTT extension. So based on MQTT and the semantics and the spec, and we build something and put our O&M data model into it. And SOS currently doesn't support pops up in the spec. The next one, updating properties of existing sensors or observations. For example, I have an observation, and then I need to update some. For example, the time. I figure out my phenomenon time is wrong, and I want to update the time. And in this case, it's very simple for SensorThings. Use HTTP patch and JSON patch. Both are RFCs, like the standards. And standard way you can update the properties, including sensors, actually including all the entities within the SensorThings API. However, SOS doesn't have that. If SOS need to support that, you need to add one more function, for example. So currently it doesn't support that. And delete observations. And similarly, in SensorThings API, you can delete all the entities you want, and so just HTTP delete. However, SOS doesn't support delete observations. For example, if I want to, these observations are wrong, right? And I want to delete them. In SOS, no, you cannot do that. There's no standard interface allow you to do that. And finally, the link data support. SensorThings, because it's JSON based, and you can directly use JSON LD if you have the good the link data. And then and for SOS, not really. There's no direct way to add the link data support. And for example, in SensorThings API, we're looking at when the joint OGC W3C working group, we are working on some SSN, semantic sensor networks ontology. When it's ready, we are ready to use that to annotate SensorThings API. So for all the entities in the SensorThings API become linked data ready. So that's the other good thing about SensorThings API. So this is a table. There are more features difference between the two, but this basically summarizes the different features. Okay, so first thing, some details here. JSON or XML. It's just a choice of encoding. So actually, I would say that this difference is really nothing, because nothing will stop SOS to have a JSON encoding extension. And similarly, SensorThings can have XML encoding extension. And for example, SensorThings use a lot of the concepts and the protocols from Oasis OData. And OData has both JSON and XML encoding. So it's if the community think we need to have XML encoding for SensorThings, I mean, we can directly, I think it's fairly easy, straightforward, and to have an XML encoding for SensorThings. Again, the great thing about having a conceptual model, so make it much straightforward. And I want to emphasize this is developer experience. SensorThings really provide a much superior developer experience, in my opinion. And actually, I personally test a lot, actually more than 20 undergrad student, a fourth-year undergrad student from geomatics engineering. So they are not computer science major, and they never learned anything about web programming at the time when I tested them using SensorThings API. And they are, without my help and tutorial, and they are able to develop very interesting IoT applications. And then, so yeah, it's the student-proven good developer experience. So, for example, developers can explore SensorThings with any web browser. So just the address bar, you can start play with SensorThings API, right? And I'll show you example, for example. In address bar, right, you can start playing with the SensorThings API. Supposedly you can see the screen, see my screen. Okay, great. And then the linking structure allows developers to explore SensorThings even without reading the spec. So if you go back to this demo, right, if I have never read the spec, and there are links I can click. So I click, oh, this is a thing. I look at those description and properties here. Okay, a thing has a data stream with a navigation link here. So let me click. Oh, I can get a data stream. Okay, let's say, what does a data stream has? Data stream has observations. Okay, so I can, from here, I can link to the data stream's observations. Voila. So actually, even without reading the spec, it allowed the developers to start explore the API. I think it's provide very good developer experience. So allow them to interactively to try the API. And again, the standard-based RESTful style that using the standard HTTP verbs and the status codes, and to create, read, update, delete entities. And there are a lot of developers are very familiar with them, so it's really lower. They don't need to read another spec, right? You just reuse what they are familiar with. So that's a good thing about SensorThings. And also, to develop application, you need a very compact code space for SensorThings if you develop a client. For example, I'm showing you a code using curl. And for example, you open your terminal on your Mac or Linux and just copy and paste this line. And you can insert observation into a SensorThings API. So change the URL and you insert to a different SensorThings. And the next page shows you how can you insert one observation with SOS. So here is the thing, right? It's a drawback of a SOAP. And it's just a lot of code. And again, there's no easy way allow you to use the tools you are familiar with, like the curl, the postman, this and that. It's just no easy way for you. And it's very easy for you to make a mistake, right? Like syntax mistake, right? And you do need a library so you can send up easily send the request. So it shows the difference between the developer experience and the code space. And by the way, code space also impact your memory and network bandwidth. So that's the other implication as well. Okay, so next one, efficiency. So what's the difference between efficiency? The difference of efficiency between the two specs. At the web transfer protocol level, so let's look at this level. So SOS is based on HTTP. And SensorThings is designed for HTTP, CoAP, and MQTT. So CoAP and MQTT are two protocols specifically for IoT. So SensorThings is more efficient in a way, and I'll more detail later. At the interface level, SensorThings offers efficient way to get the compact responses. So that means you have a different way to get only the response you want. So that means shorter response time, less data transmitted, less power consumption. And at encoding level, JSON XML. JSON is a little bit more efficient than XML. But again, as I said, it's not a very big deal. After you zip it, it's similar. Okay. So here are some comparison. I have a link to the source of this experiment. So to show the MQTT and HTTPS regarding power consumption, the blue lines are the MQTT and the yellow are the HTTP. Actually, you can see in terms of efficiency, there's a pretty big difference. And next slide also shows the power consumption differences. And then I want to bring your attention to some results here. Actually, go to the bottom, the last row. The message received HTTP actually only able to receive quarter, like 25% of the messages. In this example, actually, the person who wrote this blog and then tried to send as many messages as possible to a phone and speaking HTTP as well as MQTT. So in MQTT, the client is able to receive all the messages, but go through HTTP with a very high sampling rate. That means you collect data very frequently, and then you lose 75% of the messages through 3G. And with Wi-Fi, it's more stable, but again, you lose 50% of the messages. But with MQTT, they receive 100% of the messages. And if you look at the difference between the battery use, and it's one order of magnitude difference. So again, HTTP, by using HTTP, it's much more efficient. So some people may argue, okay, we can use MQTT and SOS. But actually, in a way, not really. MQTT has structure similar to URL path to define pub subtopics. And so actually, it's inherently, it's RESTful friendly and compatible with REST. However, it's not compatible with KVP pair encodings we use for SOS. I'll give you an example here. So look at these two examples requests. So from a SOS perspective, they are the same, exactly the same. So the first one is offering, and then for certain observed property. And the second request, you just move the observed property first, and then offering. But in terms of MQTT, they are different topics. So again, if we try to use this to define this topic structure using a SOS request, and it really doesn't work. And we can hack it, right? Like define, okay, you have to follow certain order to do this. And if you're familiar with SOS, it's quite a long list for the KVP encoding. But again, it creates confusion because you hack the MQTT, and then also it provides pretty bad developer experience because it's just, it's not consistent. So again, not a very good idea if you use SOS over MQTT. Again, the other thing is a CoAP. So CoAP is something use UDP. And a typical CoAP request header is 10 to 20 bytes, very efficient. Response code is just 1 byte. And then it supports pushing as well by introducing CoAP observe. So again, by supporting CoAP, and then SensorThings can leverage a lot of effort spent how to make these protocols more efficient. And we don't reinvent the wheel, we just use them, right? Okay, and again, for SensorThings, allow you to get to manipulate your URL pattern and to get very efficient response. For example, let's say I just want to get the result. I just want a result from one observation. So you can have this get observations like this /result. So only get the result. But however, I think I want to further. I need a smaller response. I want to save my bandwidth, right? You can $value. You only get the value of that observation's result. So it gives you a very efficient way to manipulate your request and response. So that's this efficiency has been built in SensorThings. Again, in addition to the $value, we can have the select query option. So for example, I want to get all the observations from this service, but I only need the result. So you can use select result, and you only give the result. It doesn't give you all other information, right? Just the result. But however, as you can see here, the count and next link, they're also very important for efficiency reason. Next slide I'll talk about it. Okay, so it's about pagination. So SOS doesn't provide pagination, and that means you get the observation, you get everything. Right? And then what if the observation has many different, like a large number of observations? You still need to get everything. And in SensorThings provide very advanced pagination utilities. So for example, the first example I show you, observation, top 5, skip 5. That means I get the top 5 result in the second page, and the page size is 5. So basically I get the number 6 observation and to the number 10 observations. So allow you to manipulate. So skip to the next page. And also, you can have the expand the observations. That means expand is very, very useful utility. That means you can get two entities within one request. However, it's very, very easy to get a huge response, right? So give me all the observation from certain data stream in the second example. And as a result, the next link and the count become very, very important. Let me show you. Yeah, so the next link means how to get the next page. And think about it, the sensors are keep uploading data into the service. And actually, if you are querying a historical result, you just use top and skip, and the order of your observations has been changed because there are new readings insert to it. So next link allow you a transparent way, which is to get the historical readings without impact by the new readings inserted into the service. So it's quite advanced. And the count tells you how many pages left. So how many more requests if you want to go through, scan all the observations in the service. So that's an interesting, very useful utility as well. Okay. The next we want to compare is the discoverability and scalability. In my opinion, they go hand in hand. So SensorThings is all about links and designed for easy discovery. For example, the self-link give you a unique and shortest URI, so you can index for search engine or catalog. Okay, I can identify this is the entity because this is the ID for the entity. That's a self-link. And the next link allow you to do the paging, right? So the short response time, and it's really crawler friendly. So you can write a crawler and go to next page, go to next page. And navigation link with you can write a crawler and to find the related entities, right? For relationships and the reuse of metadata. So that's very, very efficient as well, and good for discovery and scalability. So SensorThings link-based structure means easy sharding as well, because this you can easily partition your database into when your data grows, you can easily partition your database. That means scalability. And the crawler search engine I mentioned about it is very friendly for these discover services. Easy, for example, we tried to use Elasticsearch to index multiple sensor things, and it's just very designed for these purposes. However, there's no easy way to index an SOS. So there's no way you can crawl to go through all the observations within SOS. You can get observations, right? And you can get their ID, but there's no way you can go to next page, you want to go to next page, or you just write a crawler and to keep crawling your data. In SOS, basically is the only way to do it is to download. And then every time in our experience, it's quite difficult. The first download, the second download, and how do we know the second download actually? For example, the first time I download day 1, the first time I download day 2, and I can throw into my Elasticsearch and say, okay, index them. However, how do you know between these two downloads there are no new readings inserted into the day 1? Because you get observations use time and space. And in order to know the difference, or if there's any changes, updates, or new observations insert into historical data, you need to download again. And when we designed a browser for SOS, we found that's a big question, a lot of overhead over there, and end up we have a lot of hacks and try to make it possible. And we publish papers, but it's just difficult. Okay. Next one, scalability. PubSub also make you scalable. Sensor deliver data streams, and the SOS request response model means many unnecessary interaction between the clients and servers. So for example, in order to know if there's new observation insert into SOS, you just need to keep requesting the SOS. And that's not very efficient. And in many cases, there's no reading available, right? So it's difficult. Again, the SensorThings, the MQTT plus OData URL pattern and OEM is quite beautiful, actually, if you look at this example. So let's say you subscribe to this entity, so the observations for certain data stream. By read the orange part, this URL path, and it tells you what are you requesting. And it tells you how to find the metadata if you want to know the details. right? You just use the HTTP GET, you get you all the metadata. So in this URL, it gives you the information you need. And then the query options allow you to receive only the updates you want to receive. In this case, I just want to know the result. So combine these three things together, it really has a very, very elegant way and very scalable, efficient way and to get the observations or any entities in the sensor web or IoT. So that's nice. And for example, the previous query, you subscribe to result in phenomenon time, and you push you only the result in phenomenon time. So this is very efficient as well. No wasted space to unnecessary data to transmit over the web. Okay, finally, security. And actually, when we compare the security between SOS and SensorThings, actually we are comparing the security between XML and JSON, and the security between SOAP and RESTful. So the question becomes, XML and JSON, which one is more secure? And SOAP and REST, which one is more secure? And as a result, XML and JSON, I think it's an easy one because nothing prevent each other to have a different binding, right? A different encoding. So I would say it's similar. But right now, because there are more security mechanism for XML, so SOS could be more secure. And similar with SOAP, there are more existing mechanism to apply security measure on top of SOAP. So inherently, SOS can be more secure if you use that. But don't forget, SensorThings can easily provide a SOS interface, but not the other way around. So we had in SensorUp, our SensorThings implementation, we have a SOS interface. So in these cases, if you want to use your mechanism, a security mechanism for SensorThings, you just go through SOS. In this case, and but still can enjoy how you insert the readings, some developer friendliness from SensorThings, and for the security sensitive stuff, you go through SOS API, but it's not the other way around. So summary, SensorThings can interoperate with SOS. That's a great thing. And SensorThings API currently provide more features, better developer experience, better efficiency, and better scalability, and discoverability as well. And while SOS can leverage the existing SOAP and XML security mechanisms, and SensorThings can easily provide SOS interface if the SOAP and XML security are desired. And I think that's it. Today's webinar is quite long, but I hope this is very, very useful to you. And thank you very much. Coral. So is there any questions? So if you have any questions, please post with the chat window.
Hi, everyone. I just launched a poll. If you wouldn't mind answering just 2 questions while we're waiting to see if anybody has any questions about what Steve said. I know that there was a lot to digest, so feel free to think about it and email me questions later if you like. But if anything is coming to you at the moment, then just go to the edge of your screen and find the Q&A box to ask some questions. Okay, so we have a question here. Question is, have you compared SensorThings with other IoT standards?
The answer is, of course, yes. But the question, let me elaborate the question. Okay, so which standard and at which level? So first, the first question might be, are there international open standard for observation exchange and for IoT observation exchange? And I would say Actually, not really, actually, because most of the standards are focusing on the connectivity. So like the workshop I went to last week, right? They are focusing on connectivity. And I think SensorThings API is pretty unique. And to provide this semantic interoperability to exchange IoT observations, which is the sensor data, and the tasking, which is our next step, right? So there's nothing, we complement other IoT standards like all syn, all join, OCF, OIC, one M2M. One M2M provides some RESTful binding to the at the web level. However, they don't have, it's more complement. We complement each other rather than we overlap with each other. And yeah, so actually, in this case, we do compare, and it's great. These standards are working with each other. And of course, there are more, let me elaborate, there are more competing standards at the connectivity level, like OCF and all join. I talked to, last week, I met both of them from these two groups, and they told me 90% overlap on this at the connectivity level, right? And Bluetooth and Zigbee, actually, they are very, not similar, but somehow they overlap. And there are other standards as well, like LoRa and Sigfox. They're competing standard, provides similar function. But at the semantic interoperability level, or the cloud API level, if we use the fancy term here, SensorThings API right now is the only standard provide this. By the way, there are a lot of companies, they provide their own cloud API for IoT, but we don't call them standard, right? They're proprietary, lock you in implementations. Okay, hopefully answer your question.
All right, everyone, please don't forget to register for next week's webinar. I've put the link to register in the chat window. If you just go to the edge of your screen, you should find a button that says chat. You'll find the link to register for next week, as well as the link where the slides will be posted, and the link where the recording will be posted. Thanks you all so much for coming. We really appreciate it, and we hope that you found today's webinar super informative and useful. Oh, and we have a couple more questions. So first, we have, are there any web clients to visualize sensor readings from SensorThings API?
Yes, the answer is lots of them. And not only from SensorUp, it's from multiple vendors. And so, for example, 50 North has a client, can visualize SensorThings API, ComputeSalt, Envisha, Noblus has a very nice smartwatch API, the client code. So for Apple Watch, so if Apple Watch is your thing, and at the SensorUp, of course, we pride ourselves that we provide very complete solution. So we have an API or the library for JavaScript, chart, leaflet, smartphone. We have Android, we have Apple, we have Android Wear as well, if your Android Wear is your thing. Yeah, so there are lots. I think right now it's really growing. And University of Calgary has several implementations for webcams. Yeah, the ecosystem is very nice. I would say right now it is. I don't have the real number, but I would say there are more SensorThings client implementation than SOS.
We have another question. How does SensorThings handle sensor description versioning?
Ooh, very good question. Versioning. So if you use a RESTful approach, okay, there are different levels, right? So one way to handle it in SensorThings at the API level is there is something called eTag. So if you use the SensorThings are supposed to support eTag, and it's part of the OData specification actually. So you can see the eTag version number, and the versions about your entity. So it applies not only the sensors, apply to any entity, the thin, object property, this and that. So okay, the one I download or request in the past, is it the same like the one you have over there? So eTag is the standard web-based way to handle versions. I hope this answers your question. But if you go deeper into this, the versioning might also mean that I have a sensor and the sensor upgrade itself. For example, my sensor upgrade the firmware, right? And I think this needs to be handled in the data model level. So if the sensor ML, for example, if the SensorThings API go to the sensors and you link you to a sensor ML, and the sensor ML has a way to handle that versioning. So this is not at the cloud API level. It's more on a data model level. And yes, I think SensorML can support that. And also, SensorThings support multiple encodings for sensors or procedures. So other data model can support that as well. So actually, we do consider that at the different level, the data model level, as well as the web API level, which is an ETAG. Okay, hopefully answer your question.
All right, so it looks like we have no more questions. So we can wrap it up. Just don't forget to look at your chat panel for the link to register for next week, to view the recordings, and to view the slides. Thanks so much for coming, everybody. Oh, we have one more question. Awesome.
Sure.
Okay. How well does SensorThings handle the Raspberry platform?
Oh, very well. Actually, today I learned we had this morning we have a meeting, and today we learned actually there are 3 different Raspberry Pi implementations for SensorThings. So it handled very, very well. And actually, in the future, we'll demonstrate in a webinar. We'll demonstrate our Raspberry Pi solution, and both a gateway solution as well as a server solution. And so this the solution is very, very suitable for example, disaster management applications. You can bring a Raspberry Pi when there's no network, right? So you can establish a local SensorThings when there's no wide area network connectivity. So become a local hub, and then we also have the gateway, so you can log into the gateway. You can even update the firmware over the air through the gateway interface, and the gateway talk to the other Raspberry Pi. So 2 Raspberry Pi talk to each other to form a local IoT network. And for disaster management purpose, that's very nice, because if there's no network, and then you use this Pi as a network, as a local solution, but when there's a wide area network available, and then it's synchronized with the cloud. So this is one application. Of course, the easier application is a simpler one. The one I mentioned was quite complicated, but a simpler application may be just a Pi to monitor, connect sensor to monitor your house, for example. Yes, and there are lots of very, very friendly, and we will publish the code as well. And by the way, we had this Eclipse open source project, right? So yeah. You will see it. If not, no more question?
It looks like we don't have any more questions. So thanks for all of those questions, guys. And we'll see you next week.
Okay, great. Bye, everyone.
Bye, everyone.